Hi everyone, this is Michael Eilbracht from Diesel Laptops, and today in this tech tip video I'm going to show everyone how to verify engine timing with the engine running by using pressure transducers. Okay, so let me show you my hookups first, and then I'm going to do the test, and then I'm going to walk everybody through on how to ID these pulses and how to understand them. Okay, so let's go to some pictures here I have. So the first one I want to show is right here. I have a homemade first look sensor basically that I have teed into the pressure sensor for the turbo before the turbine, okay, to the turbo. This is on a PACCAR MX-13 engine, okay. And the reason why I'm going off of here is because I'm going to get better pressure pulses going into this sensor so I can see them more defined, okay. Now, the other reason I'm doing this as well is because with the back pressure on the exhaust, because of the variable geometry turbocharger, I have to put it here, that way I can look at the timing pulses accurately, okay? If I were to take this and put this all the way in the back of the exhaust pipe, the exhaust pulses would be dampened, and then the pulses would not line up properly to look at the timing, to look at my crank angle events, which are 120 degrees on this engine because it's a 6-cylinder engine, okay? So that's the reason why I'm doing this. So when you're verifying timing, you want to make sure that you put a sensor of this make, whether it's a WPS 500 or a first look or a homemade sensor, whatever it is, you need to make sure you're before the turbo, okay, so you can get those pressure pulses, all right? Now, when you're doing misfire diagnostics, that's a little bit different, because on misfire diagnostics, you want to make sure that this is in the exhaust all the way in the back, because then that's going to show all the pulses being put out through the exhaust evenly, and when there is a misfire, the misfire will occur properly on your cylinder identification. If you hook up to here before the turbo looking at misfires, what will happen is you'll see a drop in your exhaust pressure, but the problem is it will actually occur a little bit earlier, and then it will throw you off on your cylinder ID with your scope, okay? And I'll do another video about that at a later time. I just want everybody to understand why I'm hooking up like this and why I'm doing it, okay? So this is my exhaust connection with a first look, or it's a homemade 2-wire piezo sensor. That's all it is. And now I'm going to show you my next picture. Here I took a low amp current probe, and I've got a breakout lead here that I plugged into, and I've got my current clamp around number 1 injector, okay? By doing this, this is giving me a cylinder sync. That way I know what cylinder is what when I'm looking at my pressure pulse events, okay? Then I put a WPS 500 into the boost pressure sensor port right here. You can actually go online to Amazon and get the different metric fittings that you need, and I can screw right into this connection. That way I know I've got a good connection and I'm going to get good pulses. My recommendation is, when you're using these types of sensors, try to get your connection as close as possible, and if you can get a fitting to secure that connection, you need to do it this way. That's going to give you the best results, all right? Now that I've showed that connection, the next one is I have another WPS 500 in my dipstick tube, okay? By using this sensor, I am going to look at the pulses from the crankcase, and that's going to tell me the overall bottom end health of the engine, okay? So if I see, you know, all the pulses look relatively pretty even and my pressure level's okay, and we can measure the pressure with this because it's actually a pressure transducer. It measures pressure. We can actually get a whole bunch of known goods and figure out what good is, and then later on when you have a problem, you can then reference your old waveform and then see if it's out of that specification, okay? So that's the beauty of using pressure transducers, because they give you an actual reading value of what that pressure is, all right? Okay, so now that I showed you all my hookups here, next thing I'm going to do is I'm going to start up the truck, and then I will show you real quick. I'm going to adjust the trigger so we can just look at all the pulses zoomed in. That way I don't have to do a long screen and then zoom back in. So I'm just going to start the truck, I'll adjust my trigger, and then I'll show you the waveform, okay? Okay, so we've got our waveform here, okay? So, as I was saying with those hookups, the green trace here, that is the 2-wire piezo sensor on that exhaust pressure sensor connection, the exhaust gas back pressure sensor before the turbine, okay? And then the red channel here, that is the WPS 500 in the intake manifold, the boost pressure sensor port. And then this yellow trace here is the WPS 500 that's in the oil dipstick tube. Okay. Now, another thing about when you're using pressure sensors and you're going in a dipstick tube, you need to also make sure that the dipstick tube is not submerged in the oil. If it is, your pulses are not going to be very uniform. If you notice here, I've got pretty good pulses, so that means that that tube is above the oil. Okay, so that's the reason why I'm able to get some defined pulses here. So if you do the same test and you notice you're not getting as a defined pulse, it's nothing to worry about. It just means that the tube is submerged in the oil. Okay, but since we're using a WPS 500 and we can actually look at the pressure, we can measure the pressure, and then you can look at your known good. Okay, and if you notice here, my pressure is at a negative pressure right now. Okay, and the reason why this is happening is because it has to do with the ventilation system for the crankcase. Okay, so it's pulling a little bit of a vacuum. Okay, but what's cool here is you can get your known goods and reference it for later. And not only that, if you notice here, every time you see the pressure go up and then get pulled down, this is actually the power stroke right here from your engine, all right? And then it goes down because it pulls down because it's pulling in a vacuum, okay? So, but these here, these are your pressure pulses from the pistons, okay? So now, what I'm going to show first is we're going to go over the exhaust pulses first. I already set up my degree rulers right here, so I could show this to you. So if you notice here on the bottom, my degree rulers, I have them at 120 degrees apart. All right, so this is a 6-cylinder engine, and the crank angle between cylinders is 120 degrees. All right. So, with that being said, since the crank angle is 120 degrees between cylinders, I can now use that value to ID if my exhaust events and my intake events are timed properly, because they're all spaced at 120 degrees. So if I take my measurement cursors on my exhaust, okay, and let's say I measure at the very top of here, and then I go to the next peak of the next exhaust event. There we go. So if you look here, that's pretty close. We're at about 120 degrees apart. Okay. So now what's cool is once you get these lined up, you can lock your cursors here, and then you can drag these to each event and see if they're relatively close to each other. And as you can see here, they're all dead on. Okay, so that's telling me that, okay, my exhaust events look like they're in pretty good shape. They look pretty even. I know I don't have a problem with my exhaust valve timing. All right, and you can do the same thing on your intake events. All right, so the red trace, the WPS 500, I'm looking at the intake pressure. All right, and if you look here, these line up at 120 degrees. All right. So then you do the same thing. Just drag your cursors. And I'm looking at my negative poles here because that's where the intake valve is at its maximum open duration. Okay, so the very negative is the maximum that the piston is pulling down when the intake valve is open. Okay, so by looking at that, I can look at all my timing events. It's like, okay, they're opening at about the same time, which looks good. Okay. But this one, if you notice, this one's a little bit off, isn't it? Okay. And if you notice here, the pull isn't as low as the other one. So maybe this engine could use a valve adjustment. So I'm probably going to have to do that. But anyway, this is how you ID issues with your intake and exhaust, your valve train. You could have an issue with your cam. You know, there's some other variables that come into play here. But the point is, you're going to be able to ID a lot of engine issues before having to take anything apart. And this is a very quick and easy test to do, putting the transducer in the intake, the exhaust, and the oil dipstick tube. Okay, so this is a very quick and easy test. It gives you a lot of information what's going on with your engine, and it's good data because you're using a pressure sensor to measure those values. All right, so now that I showed that, if you also look at the yellow trace, look at my power stroke. They're going at 120 degrees apart right there, see? So if I move these over, there you go, 120 degrees there. 120 degrees there. Okay? So I could look at those to figure out, okay, if I've got like a worn piston, rings are bad, etc. And then also I can take my known good reading here of what I have on this engine. Okay, so another cool thing is once you start to do a lot of these types of tests, running tests, cranking tests, you're going to start to get an idea of when the exhaust valve is opening and when it shows its peak pressure. Well, what I did here is I have a couple waveforms from a Cummins ISL9 engine, and this is in cylinder, so it's showing the actual cylinder pressure inside the engine. But the style of the engine, it's an inline 6, and it also has a VGT turbocharger, and it has the same type of basically characteristics that this engine has. Okay, so I'm just going to use this as an example so everyone can understand just a little bit better what these pulses are. All right, so I'm going to move these cursors here. I'm going to unlock them, and then I'm going to show you those other pictures here. So get that unlocked. And what I'm going to do here is I'm going to show the exhaust event for the number 1 cylinder. Okay, remember this is injector number 1 right here. Okay, so the number 1 injector exhaust event is going to be basically right about here. So if I count from here, so this first exhaust event, this will be cylinder 2, this will be cylinder 4, and this will be cylinder 1. Okay, so if I take my ruler here and I count this out again, so that's cylinder 1 right here, or actually no, that's cylinder 2, I apologize. So cylinder 2, 4, and then this one is 1. All right, so if I go to the very peak here, we're talking that's, yeah, about 296 degrees, close to about 300 degrees. Okay, so now let me go to in-cylinder compression waveform that I have here. Let's see. which is this one right here. Like I said, this was on a Cummins. So what you're seeing here from this area here, this is the power stroke of the engine. All right, so the cylinder's going down on its power stroke, okay? Then the exhaust valve is opening about right here, probably about 160 degrees or so after top dead center. So then it opens, okay? The exhaust valve opens, and then pressure rushes out, and then that's how the transducer picks it up, okay? How the piezo sensor picks it up as well, all right? But if you notice here, the maximum pressure that we read on our waveform, it was close about right here. We had about 300, we got about 300 degrees on here, and then on our waveform over here, we got about 296, okay? And what we're seeing here, this maximum pressure, this is because of the variable geometry turbocharger. It's because of that back pressure that's being put in the exhaust, okay? So by understanding that, how the VGT works, how these pulses work, and how a engine compression 720 degree cycle works, we are now able to take these pulses and ID what's going on and make sure timing is correct, okay? And you can do the same thing for your intake events and also for your power stroke events, okay? So let's go back to the pictures here, and now let me show you this one. So this one here, this is for the intake event right here, because right after here, this is top dead center 360 exhaust, okay? As soon as it's after TDC 360 exhaust, the intake valve is going to open, and then it's going to show the most maximum pull right here. It's showing about 389 degrees, all right? So if I go back and I look at my intake events now, all right? So if I was looking at intake, my intake events on a 6-cylinder, the first one here, this would be cylinder 6, this would be cylinder 2, 4, and this would be 1 right here, all right? So now if I go to 1 here, and I go about, let's get that, there we go, about right here, that's when the intake valve starts to open, okay? So about 391 degrees. And then if I go here, looky there. So when my intake valve opens, it's about 390 right there, okay? So it opens at 390. And actually, I'm sorry, let me rephrase that. At my peak, it's 414 for the most maximum pull. Like I said, this isn't off of the same engine. This is an example, but it's pretty close, and that's why I'm just showing the difference between the two. But basically, if you understand these pressure waveforms and you understand, you know, a 4-stroke cycle on an engine, you're going to be able to use this technique with the engine running, okay? So that's what I'm trying to drive home here, all right? So, like I said, right there, 389 at the lowest pull for when the intake valve opens, okay? And then here, when I go back to our actual waveform, here it's showing the maximum here was at about 414, okay? So that's how you can look at these pressure waveforms, you know, to help you. Now, I can do the same thing for the power stroke, all right? So if I take this degree ruler, and I'm just going to go after the power stroke here on cylinder 1, and I'm going to go to the most maximum point, which is right about there. We have about 60 degrees, all right? So that's about 60 degrees. All right, so now if you look here on this other one I did showing the power stroke, on this one it's showing it at about 65 degrees, okay? So you're able to take all these events and put them together and see how they're timed, all right? So if you start gathering known goods, all right, and measuring these out and looking at them, and then doing these techniques that I am showing right here, this is going to make your diagnostic time a lot faster, and you're going to be able to save a lot of money for your customer. And not only that, it's going to make you more accurate, and it's going to make you look better, and it's going to make your shop look better.